Hello everyone, January 21st. Look at this, we have 32 minutes left. Alright, let's get right into it. We're gonna do gas station. That was an old problem. Let's see. Yep, old problem. Oh look, I have so many different submissions. I don't know why. Let's take a look. Gas station. There are n gas stations along a circular route, okay? But the amount of gas at the ith station is gas I. You have a car with an unlimited gas tank, and it costs cost I of gas to travel from ith station to its next station. You begin the journey with an empty tank at one of the gas stations. Given two integers arrays, gas and cost, return the starting gas station's index. If you can travel around the circuit once in the clockwise direction, otherwise -1. If there exists a solution, it is guaranteed to be unique. Okay, so what do you mean by clockwise? Like this is clockwise? If you start at station 3, index 3, so it's a 0, 1, 2, 3 is 4, right? Unit of gas, you get wait, hold on. What about the cost? Oh, there's no wait. The cost of gas to travel from. Okay, so it's not money. So we get 4 and unit of gas. Okay, travel to station 4. So that's cost 1. So you have 3 left, and then we get 5. We have 8, and travel to station 0 -2 plus 1, and then -3 plus 2, and then -4 plus 3. Travel to station 5 gas is just enough to travel back to station 3. Therefore, return 3 as a starting point. And here you can't. You can't start because I start here, I cannot reach here. I start here, I cannot reach here. Yes. So I can only start with this one. So I start with this one. I go 3, right? So I can reach here. And I guess I have 3. And then I can barely reach here. I got 3, but it requires 4. Yes. 4. Travel to 0, I have 3. Travel to 1, I have 3. It cannot travel back to station 2 because it doesn't require 4. Okay. 10 to the 5th. Okay. Okay. Okie dokie. I mean, obviously, we cannot try every single station because each try will run, so it will be O(n) squared. So that's not the ideal. So what we can think about is, so we have these gas stations, right? So 1, 2, 3, 4, 5. This is all the gas stations along the route, and we also have the cost. So when I say cost, it's just in between the distance. So we're gonna think about distance between 3, 4, 5, 1, and of course 2. Okay, so we want to find one such that we start from this position, we can go to the end. So what we can ask is, let's say if we start at 1, how far we can go? Can we do that? If I start at a position, so I start at a position with the amount of gas I have, right? If I start at a position with the amount of gas I have, then I ask how long I can travel. So let's say I started with 0, okay? So we think about it as like a dp, but it's like 2d dp. So on one side I have the starting position. So what we asking is, if I start at this position with this amount of gas, what is the furthest I can reach? So what we want to find out is, we start with 0 gas, and at a certain position, the furthest I can reach shall be itself, right? It shall be itself. How does it help? Like if I start a 0, start a 1, right, and I want to know how much the second one, and I have a starting guess for the second one. Okay, so you can keep going, all right, and it didn't go. So now what? Now I start at 2. Okay, if I start at 2 and I don't want to go through the entire thing again, so what I hope is at 3 I will be able to see uh, how that's that doesn't really work, right? Because if I start at like if I start at here with 0, then I'll have gas 2. So I want to know if I start at gas 2 with this position, how far I can go, right? But I don't have it yet, so I have to keep computing, and then I return back to this. But this process is static, right? What you do, right? What you do is at a starting point. Let's say we have x gas at position 0. So now what we want to find is x plus 1 minus 3, right? Plus 1 minus 3 plus 2 minus 4 plus 3 minus 5 plus 4 minus 1 plus 5 minus 2. And then when I go back is plus 5 minus 2. Like, so plus 1 minus 3 is the requirement to reach the second stage. To reach, this is to reach 1. Plus 2 minus 4 is to reach 2. Plus 3 minus 5 is to reach 3. Plus 4 minus 1 is to reach 4. And plus 5 minus 2 is to reach 0. So we have this. So we know the net gas the car needs to reach the next step, which is, so minus 2. So 0 requires, 0 is plus 3, which means it can gain, right? And 1 is minus 2. 2 is minus 2. 3 is minus 2. 4, to reach 4 is plus 3. So from this we can see to reach 1, 2, 3, right? To reach 1, 2, 3, if you want to reach, it's a negative. It's a negative. So if we start from any of these, you can not reach, because to reach 1, you need to start with 0, right? So reach 1, but reach 1, you require minus 2. I reach 2, so you cannot start from there. You cannot start from 0 because you cannot reach 1. Well, yeah, so you can. Wait, hold on. Can you? Plus 1 minus 3. No, you cannot. So this is starting from 0 to reach 1. You need minus 2. It's a minus 2, right? And to start from 1 reach 2 is minus 2. So all of this tells us if the value is negative, that means we cannot start from the 1 before, right? So to reach 1, so there are only 2 positions we can start. We can start from 3, go to 4, because this is plus 3. And we can also start from 4 to go to 0. This is also plus 3. And all the others are negative, right? So these are plus and plus. So in that case, we can say, and it says if there is a solution, it is guaranteed to be unique, right? So that means we just have a bunch of pluses and minuses, right? Bunch of pluses and minuses. And we know the minus we cannot start with, so we just search, right? We search for the longest streak. I mean, for it to be possible. So first of all, for it to be possible, all the plus shall be larger or equal to the negatives, right? So like if we add up the entire thing, it shall be larger or equal to 1, or larger or equal to 0. If it's smaller than 0, then we cannot do. For example, if we take a look at example 2, so example 2 says 0 to 1 is plus 2 minus 3, right? 1 to 2 is plus 3 minus 4, and 2 to 0 is plus 4 minus 3. So if we add these together, the result is minus 1. So we cannot, this one is not possible. Okay, so now let's say, so we have figured out which one is not possible. Now, if the total sum is possible to go through, the next question is, from which positive value we shall start? For that, how do we do that? I mean, basically what we're saying is, from which point going forward, right? From which point going forward? Like that's plus, so we look for all the plus, and maybe we can sum up all the pluses and minuses. All right, the consecutive pluses and minuses. How about that? We sum up the consecutive pluses and minuses. And we just want to make sure that everything is stay above 0, right? We want to make sure everything stay above 0. We can just pick the starting point. We can pick 0 to 1, right? We're going to pick 0 to 1, and that's what give us like a positive or negative value. And the next one is a positive and negative, so we just condense, right? We condense the entire field, entire thing, condense them, okay? So after we condense them, we will have like a plus, minus, something like that. Plus, minus, plus, minus. So when we have that, what do we do? So we condense them into, like, let's say 0 to something is negative, and then we can like loop around. We also have loop around. So what we have is, so position, like position k to position k plus 1, total is minus something, right? K plus 1 to k plus 2, k plus 2, like just consecutive will be plus something, and will be minus something, plus something, minus something, plus something. And then we need to look for then we need to look for what? We need to look for a point that from this point onwards everything will be positive. How do we do that? How do we do that? So we're starting from a positive value, and then we look, because it's just up and down, up and down, up and down, right? So we for each positive value, we look to its right, all right? So we find the first positive value, look to the right. If the right is bigger than the left, then we can now go from there. So we look for the next one, right? And if it's larger than, then we say, okay, that is a potential starting point. And then we start from here, right? We start from here. And then and then we're trying to compute, well, because the total positive will be larger than negative, so there gotta be one. Maybe we can just find the largest positive and start from there. Because we condensed everything, right? Since we condensed everything, and it's just going to be a negative, positive, negative, positive, negative, positive. So in that sense, the largest negative shall not be larger than the largest positive. Otherwise, if the largest negative is larger than the largest positive, what is going to happen? I mean, it could be. Are you saying like they're? No, it cannot happen. If I condensed them, right? If I condensed them, then the positives, because all the positive added together is larger than all the negatives added together, right? So even though we have a local large negative, there gotta be a big positive somewhere, right? If all the positives are smaller than negative, that's not gonna happen. So there gotta be some positive value that's larger than its local negatives. So like the largest positive value, it shall be larger than the largest negative value. So we start from there, right? And then if we start there and then cancel out, the next one is small, the next one's big. I still don't see a clear path. Even I have this pattern, this positive, negative, positive, negative, positive, negative pattern. But which positive should I start with, right? And yeah, which positive should I start with? That's a good question. If I start from one positive and I go down, and if I fail, maybe we can do it, I don't know, like cumulative sum, prefix sum. So we have a positive, and then we add this, and we add this, we add this, we add this, all the way add. And then if at a certain point, and we have all these values, and then I can compute from this. So all I want to compute is from one positive. We must always start from positive, right? So from one positive all the way to itself. So it's just from this, blah, 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 and then the last one, let's say, wrap around the negative. We just added everything, okay? We just add everything. And if it's negative, then I can move forward. Yes, I think this is gonna work. All right, so we have only 14 minutes. I am not confident we can get this done in 14 minutes. Oh, I just made a mistake. Alright. This is not helping. Alright, so here is the idea. Yeah, we might have to buy a pass for this. All right. Okay, so what we're saying is we're gonna produce zip it, all right? Zip it, and this minus this, and that's 0 to 1. And I'm gonna say net gas will equal to, for zip, gas and cost, all right? And just do gas minus cost. So the result is from 0 to 1, 1 to 2, and we say if sum gas is smaller than 0, then we definitely return minus 1. All right? And then what? Well, and then we can just produce a, yeah, I think I can just do a cumulative sum on this. All right? Let's see. The last one will be from 5. So 1 minus 2, minus 2 minus 2, 4 to 1, right? 4 to 1 plus 3, and this is plus 3, right? So what we get in this array is 0 to 1, 1 to 2, 2 to 3, all the way down to, I don't know, n minus 1 to 0. So this is the array we have. We can do a cumulative sum, right? We can do a cumulative sum, and we just go step by step. We say start from the first one, going towards the end. But you don't know if it's gonna, you don't know if along the way it's going to be negative, right? You don't know that. That's the problem, right? That's the problem. You don't know if along the way it's going to be negative. Oh, how about sliding window? Right? We're starting from a certain value, and then we just keep going to a certain point. If it's negative, that's fine. We ditch the front, we start with this, and we just keep adding. Right? And then if it's no good, we keep going until if we go back to the starting point. And then that might work. That might work. Okay, so what I'm proposing is the starting point, right? The starting point, we're gonna say, so we have the sum of this, and then we could ditch this, we plus this, ditch this, plus this, and if we go to the end, so starting from this, we can ditch this, plus this, and eventually, right, and start from this, and then we keep going until this one catches up, right? If it catches up, then we're good. And if we keep going, okay, so we're gonna say a left and right, okay? So I'm gonna say left and right. We start them like this, and then we say while left is a starting point. Okay, so while, no, let's just say this will be the start and end, right? So we say while start is smaller than len, net gas, okay? So the starting point cannot go to the end. Well, starting point and go out, and then that's gonna be, so we're gonna go blah blah blah. If this is there, we're going to turn minus 1, okay? So start is smaller than this, right? And then we're gonna say if end is equal to start, which means goes back, then we're gonna return start, right? But the starting point, if I have a start as here, I need to know how far I can go, right? So I need to first compute how far I can go. No, I think it's just start. There's no end. The start is this, right? And then, well, in this case, maybe just say for I in range len net gas, right? And then, because I is the starting point. And then we're gonna say while, and which is sum, right? Sum net is 0. Okay, so while sum net is larger or equal to 0, then we do sum net plus equal to net gas I. Oh, we need, so this has to j equal to I, right? Sum net and plus equal to net gas I. Okay, so and then it's fail. It's fail, then we go I plus equal 1, and then J, keep going. Okay, so this is no. We have to do wow. So start. Wait, hold on. Let me think. So we're gonna start, blah blah blah, and then keep going, and we'll meet. If we cannot meet, I will go forward. Then the sum net should be on the outside. This shall be on the outside. Okay. Sum net shall be on the outside. And then every time we go, and then J shall also be on the outside. So J equal to 0. Okay, so we don't have this. So while this, our sum net logic is 0 plus equal to net guess J, right? And then J plus equal 1, right? J plus equal 1. And then if it come out, if it's not, I mean, it breaks out. Sum net. So while this and J is smaller than I, because J will have to go around, right? J needs to be smaller or equal. Oh, but if J is smaller than I, we cannot even start. The start is 0 and 0, right? Starting 0 0, and then it cannot go. So J need to be smaller or equal to I. I is the starting point. Oh, we can do this. Sum net will be net gas 0, right? And J can be 1. And then for I is starting point, right? And then we're looking at J. J is the next target, right? We're looking at J's next target. And we say, while this logic is 0, and then J is smaller. No, J is not. J is larger or equal to. And we keep going. When J is equal, larger than. When J is large, no, when J is not equal to I. J is not equal to I, and we say sum net plus equal to net gas J, and then J plus equal 1. We'll go to the next one. So we keep going, and if the sum net is smaller than 0, so when it breaks out, then we're going to check, right? What we're going to check is, so plus 1, it will come here, J equal to I, right? So we say if sum net is smaller than 0, right? If sum net is smaller than 0, then we fail, right? We fail. So some type of failure. We fail here, right? And then if J is equal to I, which is sum net, and then this means we can return I. I is a good starting point. Okay, so how to handle the failure case? So if we fail, which is sum net is smaller than 0, so what we do is I need to go forward and J stay where they are, but we need to make some changes, right? Make some changes to, so let me see. So when this happens, sum net, right, we need to remove the I because I want to move forward, right? We want to move forward. We need to remove I, so sum net minus equal to net gas I, because we sum from I to J, right, and J plus 1, so J move on to the next one, and now sum net is a negative value, right, so it's no good, so we break out, and then sum net minus the I, so I will take I away, and I move forward, right? And I will go again, we try sum net. If it's larger than 0, then we add the gas J. So we keep going. All right, let's try this. I mean, in this case, maybe we don't even need this. Maybe we don't even need this because this one, I will try the starting point and everything. And all right, we don't have much time. We're really cutting. All right, so let's just run it here, see if we can pass both test cases. If we can, at least we submit. If not, I mean, we have to, oh my God, cannot assign the function call. What the hell happened? Oh, my bad, GC for GC in. Okay. Let's see. That is not correct. Oh, we're probably not gonna make it. All right, if we're not gonna make it, we have to pay. All right. How do we pay? Yeah, we're not gonna make it. We're not going to make it. It's fine. I mean, that's disappointing, but we're going to buy. I think I can buy it right now. Let's see. Store. Redeem. We have enough coins. We have enough coins to redeem. Let's see. I'm gonna buy one of this. Okay, I'm gonna redeem this. All right. All right. So let's figure out why this one's not right. Yeah, we just didn't have enough time. All right. So this one shall start at 3. This one shall be -1. Okay, so this is gas cost can complete gas cost. Huh? What? Oh, my bad. All right, that's not right, right? So we're gonna do this. Let's print net gas. Okay, that is correct, right? So we say sum net gas is -2, j is equal to 1, so j is pointing here. And while sum net is logic, it's not. So sum net minus equal to gas, that's 0. So it should be 0, right? And then we keep going on. So I point into this one now. So I point into this. And I point into this. This is our starting point. If this is our start, hold on, let me think. So we move forward, right? Now we still need to resolve the issue of they're equal. So that is the starting point. And +1. So maybe I shouldn't do this. I should start with 0, right? So start with 0, just be 0 as well. And then we check this one here. So sum net plus equal to net gas j, which means this take us to the next level. And this is larger than 0. Hold on. The starting point is a little bit tricky. So we start here, and then it's negative. So I'm going to move forward. But j is also staying in this position. So what do we do? J is also this position. It's saying when we move forward, did j also move forward? So we do have to consider these two are together, right? So these two are together. So I'd say I add -2, and then j gonna plus equal to 1. And then coming out, -2 is no good. So we come here, so -2, no good. So j gonna plus equal to 1. Okay, so which means, but how do I identify? How do I identify when j needs to equal, because it will wrap around, right? J will wrap around and then catching up. And the j catching up, so j plus equal 1, right? And then j plus equal 1, so now logic is 0, and then you check if j is equal to I. J is equal to I. I need a flag. Okay, I think I need a flag. Flag is initiate. Initiate equals true. Okay, so coming in, while this larger than 0, right? And initiate or I is not equal to j. Okay, then coming in, j plus equal 1. So once we do this, initiator will be false, right? It will be false, and right, initial will be false, and then we come back up, initial will be false. So I need to check this. So whenever this comes out, if it's smaller, if this okay, so if it's some that is smaller than 0, right? If it's smaller than 0, then this one minus equal to this, which is fine, perfectly fine, and it's minus this, right? And if it's minus this, and then if I catching up, so we're gonna say if I plus 1 is equal to j, which means I catching up to j, then we're gonna say initiate equals true, right? So we're back to the true. It's gonna be the initiation, right? Otherwise, doesn't matter, right? Otherwise, doesn't matter. So the last thing is j plus equal 1. So j shall equal to okay, j plus equal 1. Now I need length, right? Let's say n equal to len gas, net gas. Then we will have to do this and be n. And then here we say j plus equal 1. And say if j is equal to n, j equal to 0, right? So initiate is false. Okay, so let's try this. Now this one pass. Try this. Now both pass. Okay. Let's put these together, sum and then 0. And then we go through this. Yeah, this shall be good. So now before we do this, start using. Okay. All right, and then we click this, and I'm going to try to use the ticket that we just bought. Okay, so I'm going to do this and use example, try it. Okay, let's submit it, let's see what happens. We pass, okay? This is the daily code challenge for January 21st. There are 2 incomplete challenges, and you have 1 ticket left for this month. Sure you wanted to make up this? Yes, I want to use a ticket to make up for this one. Okay. So then if I refresh this, okay, so this one I think is good. The gas is good. Okay, now we need to handle the situation why in the past I got a 56. Now it's 741. All right, so for one thing, I mean, this is ON, right? I mean, we can. Let me see. If I say let's say sum net gas is smaller than 0, then we immediately return -1. Would this make it faster? Let's try. Not really. Enjoy. Not really. I'm not gonna include this. All right, so let's write our thoughts. We did solve this, but we solved it just for too long. Okay, so this is LeetCode, and this is 134. It's not an easy problem, man. All right, so we say the idea is to produce a list of net gas usage from gas station to gas station, right? Then we use a sliding window technique to find out whether starting from one gas station, the longest non-negative cumulative sum, right? That's not cumulative sum. The longest cumulative sum that does not have any negative element can reach back to the starting point. The benefit of sliding window is that once we have computed a range, and it doesn't work, right? It doesn't work. We can simply ditch the starting point and continue. I just realized this is actually, I don't think this is correct. So what he's saying is from a starting point, and everything is positive, and then we do one more to become negative, right? Which means starting from this is not going to work. Then if I ditch this, if I ditch the starting point, now if the starting point is a negative thing, right, then it will make the whole thing positive. Hold on, let me think about it. If the starting point is a negative, right, and then everything added together, it becomes negative. And if the starting point is negative and nothing along the way makes it negative, so they're all positive, and then we add something, and it must be a negative thing to make it negative, so there's too much negative. So if I remove this, right, so this is all positive, and we add something. So the question is, if we add something and then we remove this, if the something we add, okay, remove this, and of course if it's still negative, then that's no good, right? That's no good. But if it's positive, does that mean along the way everything is positive? Yes, it is, because if it's negative along the way, they have to be positive. Now if this is a positive value, right, then I remove, and then we end up with a negative. It's a big negative, right? It's a big negative, so it become negative. So I remove the positive, they all continue to become negative. So it's actually true, it is correct. Consider ditch the starting point and continue. All right, and if we exhaust, if the endpoint catches up, right? Catches up to the starting point, we have our solution, our result. Otherwise, if the starting point exhausts the entire array, we know that there is no solution. And this is ON. This is ON. And we run in a measly 741 milliseconds. That's terrible. And the previous best, okay, here we have is 48. Let's take a look how they look like. And this is fine, right? And we have an initiate just to make sure that they won't meet each other, right? So initiate equals false, and this will set initiate to true, and this is they're actually catching up. Maybe we don't need. Hold on. I don't know. Yeah, I don't know. I think this is. Oh, is this? Oh, they changed the test cases. 35, 31. They added way more test cases now. All right, so this is only 22% ranking. All right, 22% ranking. Let's check the correct. All right, so diff size current max consecutive positive count. Current max, so we keep consecutive positive count plus 1 if current max is 0. Else we set it to 0. Oh, that's it. Hold on, let me think. Current max. So the current max diff plus this is the wraparound. Nice. That's the wraparound. Okay, I see what you did there. That is the wraparound. So we wrap around and we say current max equals current max and a current max plus D and a D. Okay, so we get the D, right? We get the D and we keep going. So wait, is this Kadane? This seems like Kadane. It's like the maximum value you can get ending at a certain position, right? The maximum I can get ending at a position. So we say the maximum I can get ending at this position. So we're starting from any point. So I just trying to find the maximum we can get ending at this, right? And if current max is larger than 0, that's the first, and then next one larger than 0, next one larger than 0, larger than 0. If it's negative, what if it's negative? What if it becomes negative? Well, if current max plus this becomes negative, then the consecutive count will be 0. and the current max will be the current max. If the current max is a negative value and then we plus a positive value, we definitely pick up the positive value. So it's just guaranteed that the starting point will always be a positive value. It will not be a negative value. Okay, so the starting point will always be a positive value, and then we just count the consecutive positives, right? At a certain point, if it drops, then consecutive count becomes 0, and the current max we try to pick up the next one, and then we keep going. That's the new starting point. So it is, we try every single one as a starting point. We try this one as starting point, this one as starting point. So one is a starting point, we keep going, and if it fails, right, what we're saying is when that happens, we don't try the next one as a starting point. Why? We can just keep moving on. We try this one as a starting point. Right? That's what it's saying, because the current max just keep increasing. Current max keep increasing, and at a certain point, it becomes negative, right? So current max plus d, so it becomes something negative. And then we go up, it's negative. So these are just not good. So why don't I try this one? Because from this, let's say from one point to a point that we got negative value, right? I don't try from the next one. What if from the next one it's successful? If from this point is successful, if from this point is not successful, you're saying from the next point will also not be successful. Why? If from this point is not successful, so which means this range is a negative value, and if this is a positive value, then it's true to the next one. If it's a positive value, no matter what, it's going to be negative because this whole thing is negative, right? And now when minus a positive value, it becomes even more negative, right? But what if it's a negative value? What if I eliminate it and from this it becomes positive? And what if it can wrap around? I don't know. I don't know why this one is correct. Yeah, what if I can wrap around? And in this one, we just ignore. We're just immediately starting from the next position. Like, that will be the... I minus size plus 1. Hold on. What are we looking for? We're looking at the end point. Current max is the end point, the maximum value. The maximum value I can get ending at myself is either me or current max plus me. The current max plus me. It is the consecutive consecutive values plus. So I look at me. I want to see if this is the. I can say just the previous. I think current max is a misnomer. What it is just the previous value, the maximum that can end up in this one, right? So either this plus me or that's Kadane. That is Kadane. Pretty sure in one of these I probably say Kadane. This is Kadane. So what we're trying to find is the maximum subarray sum ending at each position. maximum subarray ending at each position, right? And we want, if this is a positive value, if it's positive value, we increment the consecutive. But if it's a negative value, then we do 0. We zero it out. And we still keep going, but because this is still the largest that can end up here. So I think I probably say Kadane. It is Kadane. It is Kadane. Yeah, Kadane. Current position cannot be the starting position. Yes, so plus equal 1. And I'll try it again. And it cannot be. So the largest ending at this position is not right. But we keep going until the current max is becoming positive. The current max, which is the maximum ending at this position, right? The maximum ending at a position, it's a negative. And then the maximum ending at this position is a positive value, which is just itself, right? Which is itself. Current position cannot be the starting position. Start equal to I plus 1. Now this is just like, that's the end, right? That's the end. And what do you mean by start equal to I plus 1? If current max is smaller than 0, it's saying like plus this becomes smaller than 0, right? Which means all of these are positive. So this plus this, everything is positive. And then we add this, it becomes negative, right? It has to be. It has to be. Yeah, it becomes negative. So if it becomes negative, it's because we add a current I, it becomes negative, which means everything starting from in between is not going to pass the current one. That is correct. This is the last one. So it has to be, this is better. This is better. Yep. All right, let's write it out. I think if like given a little bit more time, or I'm not that urgent, maybe I can get it. So yeah, this is indeed Kadane's algo. Replicated from my submission more than a year ago. Okay, so the Kadane, we'll do this as usual, right? And then I'm going to say for I ng in enumerate, right, net gas plus net gas minus 1. So this is a smart way to loop around. So I just say loop around, right? Wait, did we do the loop around for this one? Did not. Huh. This one did not do loop around. Largest ending at this. Largest ending at this. Wait. Is this correct? This is actually not correct. Because it could be like, wait, hold on. So we come to the starting point, right? And then we add and boom, we have a negative value. And we know we add I and we get a negative value. That means if we start from anything in between. No, that's, hold on. we add the current one, become negative. And if we start, now it's guaranteed we always start from a positive. Okay, we start from a positive, because if we start from a negative, it's just going to be negative. And then we're going to start, okay, so it'll be positive. And then blah, 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 once we're done, and then boom, we hit a negative, and it becomes negative. So along the way, it's all positive. So if we remove this, remove a positive, it actually becomes more negative. So it's meant to be negative. If we remove this negative, because we have a positive, so we are removing a positive. So it makes sense. It makes sense. So therefore, none of the ones in between can serve as a starting point. So the starting point has to be the next one, right? The next one has to be the starting point, and has to be the starting point. And then we keep going, right? So then we start from this, and blah, 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 we go to the end, right? We go to the end. All we can say is from this point, go to the end, is all positive. But we never handle the wraparound. Yeah, this, never do the wraparound. We just say, right? We just always said is starting at this position, right? Now ending at this position is positive. Ending at this position is positive, and they're all negative, right? So negative, 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 and we ending at this position is positive, and this position is positive, and we know the total sum. Okay, so what we do is I think I see. The point is we find the sum of the max subarray, right? We find the sum of the max subarray. And if that subarray sum is a positive value and total sum is also positive, then it's, oh, this is so good. This is so good. This is so good. All right. So the idea is to find the max sum of the subarray, maximum of a subarray within net guess. This can be done via Kadane's algorithm. Once this once the max sum of the subarray is found, and the sum of net guess is non-negative, then it is guaranteed that we can visit all the gas stations. Yes, it is guaranteed we can visit all the gas stations. Another important point is that along the way, right, if the max is that in Kadane's algo, we keep track of the max sum ending at a particular position in net gas, right? We keep track of the max sum. If this max sum becomes negative, then we can be sure that the the potential starting point must be the next. Oh, how do I explain this? We keep track of ending at a particular position I. If this maximum is negative, then we can be sure that the potential starting point must be I plus 1, because if the starting point is anywhere before I, it is guaranteed. It is guaranteed that we will reach a negative sum at I. All right, so let that sink in. If this max sum becomes negative at position I, then we can be sure that the potential starting point must be I plus 1, because if the starting point is anywhere before I, it is guaranteed that we will reach a negative sum at I, right? It's because the maximum sum, right, from whatever starting point to I is a negative value. And if we remove the ones before, because the one before is all positive, right? Everything added is all positive. So if we remove positive, it's going to become more negative. So this is true, right? So in this case, that's true. We don't need this. We don't need to loop around. Right? No need to loop around. We just say no need to loop around. So all we need is max sum end at I equal to negative math.inf. So I'm going to say import, all right, math, and then for this I'm going to say max this will equal to max sum and plus d and plus and this is negative guess, right? And we say if this, and also starting point, I say start shall equal to 0, right? And if this is smaller than 0, should we say smaller equal to 0? No, smaller than 0, right? If it's smaller than 0, then we say the starting point must equal to I plus 1, because it cannot be I, it cannot be anything before I. And once we're done, we're going to return minus 1 if sum net guess is smaller than 0, else start, right? And they pass. I think that is true. So we're going to run the exact same, right, as we done the last time. But I made the code a little bit clearer. Yeah, it is Kadane, right? It is Kadane. 510. That's about right. Both are 01. I mean, this one is a sliding window, right? It's the same thing. It's the same thing. But this definitely, it requires more thinking. It requires a lot more thinking. 5, 10, 49. All right, so based on the 1 hour rule, that's the only problem we can solve. But we're going to do tomorrow as well. So I'm going to end now and then do one more for tomorrow. All right, I'll see you guys in a little bit. Adios.